Good morning, everyone. Myself Anil Kumar Chaudhary, Assistant Professor, Department of CSE, Narayana Engineering College, Gudur. Today we will discuss about automata theory and compiler design. First, we will learn about automata theory. What is automata? Automata is a self-acting machine. Automata theory is study of machines that can read input and give output. These machines are the mathematical models. Automata theory helps us understand how computers read the data and how computers make decisions, how programming languages work, how and also how compiler check our program. So automata theory is the basic foundation of computer science. Here we can discuss about what is automata. The word automata means a self-acting machine, or it is a mathematical model. It takes the input and process according to the rules and gives the input. It moves from one state to another state. For example, just like a fan having regulator. Regulator contains different states of speed 1, speed 2, and so on. The automation also has a states. Why do we study automata? We study automata to understand how computer reads the letters, how compiler check if a program is correct or not, and also how patterns like passwords, emails, or URLs are validated. If authenticated user enter the correct password, he can move to the next state. That means we can move to the next slide. Here here different types of automata. First one is finite automata, second one is push down automata, third one is Turing machine, and another one is linear bounded automata. We can move to the finite automata. We will discuss about some grammar. What is a grammar? Grammar is an formal set of rules to validate the string or to form a string. For example, according to the Noam Chomsky, grammar can be divided into four types. First one, regular grammar. Regular grammar accepted machine is finite automata. These are the finite automata, push down automata, Turing machine, linear bounded automata are the mathematical machines. It is not a physical machines. For example, in finite automata accepts regular languages. That means regular grammars. Regular grammar is a restricted grammar. Regular grammar is a restricted grammar. Its equivalent machine is finite automata. It is a type 3 grammar according to Noam Chomsky. Next one is context free grammar. It is a type 1 grammar. Its equivalent machine is push down automata. In push down automata accepts context free languages and context free languages and context free grammar, and also accept regular grammar. It is a type 1 grammar. Next one is linear bounded automata. It is also a machine. Turing machine, linear bounded automata accept context sensitive grammar and also context sensitive languages. It is a type 2 grammar. Now another most grammar is context in recursively enumerable languages. Its equivalent machine is Turing machine. Here today we will discuss about finite automata. What is finite automata? Finite automata is a simplest machine model in automata theory. It has finite number of steps. It means countable number of states. State can be represented with capital Q. Next one is input string. It can be represented sigma. For a sigma means it is an alphabet. Alphabet means set of symbols, either lowercase or uppercase or 0 to 9, or that means numbers or special characters. And also transition. Transition can be represented with do. It can transition means we can move from one state to another state. Finite automata is a mathematical model. A mathematical model can represented with capital M. Capital M equal to Q comma sigma comma tau comma dou comma Q naught comma F. Here Q means set of finite number of states. Next one, sigma means input alphabet, and also tau means transition function, and also Q naught means set of Q naught means start state and F means final state. Finite automata, for example, here we can give the correct input, machine goes to the final state. If you give wrong input, machine goes to the dead state or non-final state. Representation of finite automata. Finite automata is represented with three ways. First one is mathematical representation. A finite automata mathematical representation is represented with 5 tuples. Those are Q, sigma, tau, Q naught, F. Here Q is the finite set of states and sigma is the input symbol or input alphabet. Tau is the transition function. Q naught is the start state and F is the final state. Another representation is transition table representation. Table means it represented in tabular format. It contains rows and column. Rows contains number of states. Q equal to Q naught comma Q1 comma Q2 comma and so on. And column contains input symbols. Input symbols are 0 or 1, 2, 3, 4, 0 to 9. And are A, B, C and so on. Likewise. Here another one more representation is available, that is the transition diagram. This is the graphical representation. It is represented in graphical form. Here starting state represented with arrow followed by single circle and final state represented with double circle. Arrow means the transition. Arrow means the transition. We can move from one state to another state. We can use arrow symbol. And also in exam we can write finite definition is finite automata is a mathematical model that reads the input symbols one by one and change the state according to rules. For example, if you starting stage is Q naught. If you give 0 on Q naught, we can move to the Q naught to Q1. And once again we can give 1, we can move from Q1 to Q2. Likewise, it moves to the final state. It moves to the take the input and moves to the final state. The string is accepted. Otherwise means it is going to dead state or non-final state. Here finite automata contains mainly 3 components. First one is input tape. Input tape can divide into number of cells. Cells contain input type contains alphabets like A, B, C, D and so on. String alphabets. For example, it reads only one input at a time, and also read header. Read header reads only one symbol at a time and it moves from left to right. Finite control controls all the input type and read header. In real world example, imagine you have a door lock that opens only if you enter the correct 2-digit code, that is 10. For example, 10. If you press first digit should be 1 and second digit should be 0. This is the finite state example, finite automata example. Here q0 is the starting state, q1 we can move to the q1. If you enter, if it reads 1, it moves to the q0 to q1, and then we can give 0. It moves from q1 to q2. That is the final state. The lock is open. Otherwise, it is going to dead state or non-final state. In real world scenario, we can check OTP check. When you enter OTP digit, the system check digit by digit. Here finite automata contains read header. It reads one symbol at a time. It reads from left to right. Each digit moves the system to the next state. And one more example is finite password validation. If a password contains exactly 3 letters, each letter moves to the next stage. If you enter more than 3 letters, it can move to the rejected state or dead state. And also traffic signals. Here 3 lights are available: red, yellow, green. These are the state. And also elevators. Elevators contains the floor 1, floor 2, floor 3 are the states, and inputs are up and down, up or down buttons. Transitions are move between the floors. Finite automata can be categorized into two types. First one, DFA and NFA. DFA stands for deterministic finite automata and NFA stands for non-deterministic finite automata. What is finite automation? It reads input symbol, it reads symbol by symbol and moves between the state. It helps to check whether the string is accepted or rejected. DFA means deterministic finite automata. Deterministic finite automata means it only fixed path, only one fixed path. It takes the input either 0 or 1. It moves from one state to another state, only single path. For every input symbol, only one next state is possible. Here some rules are there in DFA. Only one transition for a symbol, no confusion. Machine always knows where to go. Only single path is recommended. For example, ATM pin check works like a DFA. If you enter correct pin on fixed result, one fixed result, that is access. If you enter correct pin, we can access the ATM amount. Otherwise, you can enter the wrong pin, it is denied. In NFA, here NFA, non-deterministic finite automata. NFA stands for non-deterministic finite automata. Here many possible paths. For one symbol, the machine may have 0 transitions or one transition, more than one transition. In DFA, only one path is available. Example, here one real-time example is Google search suggestion. If you enter a number of words, suggestions are appear. That means it shows multiple paths. Thank you for watching.